Could a gamma-ray burst wipe out life on Earth? The most dangerous thing in the universe. Imagine for a moment that everything you know, every person you love, every memory you've ever made, every achievement of human civilization, could be erased in the time it takes to watch a movie. Not by climate change. Not by nuclear war. Not by an asteroid. But by something so powerful, so unimaginably energetic, that it defies human comprehension. Something that happens every single day somewhere in the observable universe. Something that, if it happened close enough to Earth, wouldn't just end life, it would end everything. This is the most dangerous thing in the universe. And it's coming from somewhere out there right now. A silent killer. The year is 1967. The Cold War is at its peak. American spy satellites are scanning the globe for any sign of Soviet nuclear testing. The Vela satellites, their name taken from the Spanish verb, to watch, are doing exactly that, watching. But they find something nobody expected. On July 2, 1967, these satellites detect a flash of gamma radiation. Not from the Soviet Union. Not from Earth at all. From space. The signal is brief, less than a second, but impossibly bright. For years, military scientists are baffled. They classify the data. They assume something is wrong with their instruments. Because what they're seeing shouldn't be possible. It takes decades to understand what they actually witnessed. Today, we call it a gamma-ray burst. And we now know that in that single second, the Vela satellites detected more energy than our Sun will produce in its entire 10 billion year lifetime. Birth of a cosmic monster. To understand what a gamma-ray burst is, you first have to understand stars. Specifically, the ones that live fast and die young. There are stars out there so massive, so impossibly large, that they make our Sun look like a grain of sand on an infinite beach. These are the Wolf-Rayet stars, stars with 30, 40, even 50 times the mass of our Sun. They burn through their fuel at terrifying rates. Our Sun will live for 10 billion years. These stars? A few million, and they don't go quietly. When one of these giants dies, its core collapses. The outer layers crash inward at speeds approaching the speed of light. And then something happens that physics can barely describe. The core becomes a black hole. But as matter rushes in, some of it doesn't fall inward. It gets channeled into twin beams, jets of pure energy shooting out from the poles at 99.999% the speed of light. These are gamma-ray bursts. The most focused, most powerful explosions in the universe since the Big Bang itself. In a matter of seconds, a single burst releases more energy than our Sun will produce across its entire existence. But here's the thing that keeps astronomers awake at night. You don't have to be close to one to die. The invisible apocalypse. If a gamma-ray burst went off in our galaxy, pointing in our direction, we wouldn't see it coming. There would be no warning. No second chances. No Bruce Willis flying up on a spaceship to save us. The burst itself would be invisible. Gamma rays don't interact with our atmosphere in ways that create visible light. At least not at first. 1 second, everything is normal. The next, the upper atmosphere is being bombarded by more radiation than it has encountered in billions of years. The immediate effect? Our ozone layer, the thing that protects us from the Sun's ultraviolet radiation, would be destroyed. Completely, within seconds. Now, you might think, okay, the ozone layer is gone. That's bad, but does it kill me right now? No, but what happens next does. The cascade. Without ozone, the Sun's ultraviolet radiation reaches the surface at full strength. Not the filtered UV you get on a sunny day at the beach. Full spectrum, unfiltered, sterilizing radiation. The first to die are the phytoplankton. These microscopic organisms float near the ocean's surface, forming the foundation of virtually every marine food web. They have no protection, no way to escape. Within weeks, they're gone. And when the phytoplankton die, everything dies with them. The food chain collapses from the bottom up. Fish starve. Then the animals that eat fish. Then the animals that eat those animals. The oceans, which have teemed with life for billions of years, become dead zones. On land, it's no better. UV radiation bombards the surface. Plants wither. Animals that survive the initial radiation face starvation. The food webs that sustain terrestrial life unravel just as quickly as those in the oceans. The smoking gun. Here's where this stops being theoretical and starts being terrifying. Scientists believe this has already happened, not once but multiple times in Earth's history. Approximately 445 million years ago, during the Ordovician period, Earth experienced a mass extinction. About 85% of all species died. For decades, paleontologists were puzzled. The usual suspects, volcanoes, asteroids, climate change, didn't quite fit the evidence. Then they looked closer. The extinction pattern was strange. Species that lived in shallow water died at much higher rates than deep water species. Organisms that spent part of their life cycle near the surface were devastated. Those that lived in burrows or deep water survived. It was exactly the pattern you'd expect from a gamma-ray burst. The leading hypothesis? A gamma-ray burst from a nearby star, maybe 6,000 light-years away, swept over Earth. It lasted seconds, but those seconds triggered a cascade of destruction that took tens of thousands of years to fully play out.
And that's the part that should terrify us most. A gamma-ray burst doesn't need to hit Earth directly like an asteroid. It doesn't need armies, fire, or impact craters. Just a few seconds of radiation from thousands of light-years away could quietly strip away the shield that makes life possible. And if scientists are right, it may have already happened before. 445 million years ago, something wiped out most life on Earth. Not with noise, not with warning, but with a silent flash from deep space. In the next part, we'll answer the question that matters most: could it happen again? And if it could, are there stars in our own galaxy pointing directly at us right now?